you all for joining us for the Anderson Lecture Series today. My name is Beatrice Atenka, and I'm the chair for the John Muller Anderson Lecture Series, Anderson Lecture Series. And in this capacity, that is in the School of Visual Arts, which is also sponsoring this program. And in this capacity, I serve and coordinate and by programming the Anderson Lecture Series along with the events and award committee members. This is actually a wonderful space that has been provided to us by the Pattee Library, led by Lauren Davis. So I would like to extend a thank you to her and her team, and to everybody that made this possible for us to feel comfortable to listen to the lecture today. Now, a brief history about the lecture series. Dr. John Muller Anderson, Professor Emeritus, was the Ivanpur Research Professor of Philosophy and the first director of Penn State Institute of Arts and Humanities. His passion for the philosophy of art and painting resulted in his generous gift, from which we all kind of benefit from it greatly. And some of the benefits is by inviting artists over to have a lecture with our graduate students and everybody else, the faculty and the student body, the entire school, so that we can also learn about outside of art school. The John Muller Anderson Endowment in Visual Arts was established in 2001 with the purpose of supporting outstanding programming, such as this lecture series and related activities with guest artists we bring to our campus to interact with our students and community. All Anderson events are free, so next time you come around, please bring someone. And I would also like to thank the former director of the School of Visual Arts, Wagner Mendoka Whitehead, the interim director, Eduardo Navas, and my SOFA colleagues in the Events and Award Committee, who have continued and greatly contribute to the smooth and successful carrying out of this series we would be experiencing in this season. So we have a lot coming up as well. I now want to invite onto the podium Christine Millett, a professor in the School of Visual Arts sculpture area here in Penn State, who will be introducing our artist, our guest artist, Heather Dewey-Hagborg. Thank you.
Thanks, Beatrice. So good morning. As Beatrice said, my name is Kristen Millett. I'm a professor of art in the School of Visual Arts, and it's my pleasure to welcome you all today to the John M. Anderson Lecture Series. We are extremely fortunate to have an artist who is questioning the boundaries of art and science, Dr. Heather Dewey-Hagborg. Heather is a transdisciplinary artist and biohacker whose work explores identity, genetics, and surveillance. She is perhaps best known for her work called Stranger Visions, a series of portrait sculptures based on her analysis of genetic material. Heather extracted DNA from trash she found on the streets of New York: hair, cigarettes, chewing gum, sources of genetic detritus that we all discard without really thinking about it. She used this genomic data to determine gender, ethnicity, skin tone, hair color, and other factors, along with face-generating algorithms to produce speculative portraits. So her lots of words here. Anyway, her biopolitical art practice is highly controversial and provokes debate about the potential use and misuse of DNA profiling, also privacy and genetic surveillance. She asks questions such as, how much can I learn about a stranger from a hair? Is it possible to fall in love with someone through their DNA? Could I make a virus that infects the world with love? Heather holds a PhD in electronic arts from Rensselaer Polytechnic Institute, a Master of Professional Studies in Interactive Telecommunication from NYU, and a BA in Computer Science from Bennington College. She has shown her work internationally at major venues such as the World Economic Forum, the Tejon Biennial, the Walker Center for Contemporary Arts, the Philadelphia Museum of Art, and PS1 MoMA. Her work is held in prestigious public collections, including the Centre Pompidou, the Victoria and Albert Museum, San Francisco Museum of Modern Art, the Auditorium, and the Wellcome Collection, among many others. Her work's been widely discussed in the media, from the New York Times to the BBC to Artforum and Wired. She's also the founding board director of Digital DNA, a European Research Council-funded project investigating the changing relationships between digital technologies, DNA, and evidence. While I've followed Heather's work for years, I actually saw one of her pieces called Probably Chelsea at the Perth Institute of Contemporary Arts in Perth, Australia in 2018. So suspended in the gallery were 30 possible portraits of the whistleblower Chelsea Manning, algorithmically generated by an analysis of her DNA. Heather had contacted Manning while she was in prison and convinced her to send cheek swabs and hair clippings through the mail so that Heather could extract Manning's DNA. So as I walked through the gallery, the eyes of each of these portraits seemed to follow me. It was really creepy. And I was struck how widely varied the portraits were, even though they were all based on the genomic data of just one person. Heather's work makes visible what is often invisible, heightens our awareness of and relationship with our own biology, and triggers a visceral understanding of the social impact of new technologies. So after my brief introduction, maybe you're thinking about your DNA, the DNA that you were inadvertently leaving all over Foster Auditorium. I know that I sure am. So without further ado, please join me in giving a warm welcome to Dr. Heather Dewey-Hagborg.
Okay. Hi, everyone. Thanks so much for that really great introduction. So I'll reiterate a lot of that stuff in a different way. And I think it's really nice to kind of already start thinking about the ideas. And then we'll go into things in a lot more depth. There's a lot of different work I could share with you today. So I'm going to focus on 4 bodies of work that deal with DNA, prediction, probability, profiling, and privacy. So there's some work that we won't get to, but I'm really happy to talk about any of those things when we come to the Q&A. So if you have any projects that you want to hear about, for example, the virus that Kristen mentioned, I'm happy to also talk about the Love Virus project or anything else that you might be interested in. So my background as an artist, I started in undergrad putting together code and electronics and art. And I was really interested in this kind of the new media installation approach. And then over years, I worked on artificial intelligence related projects. And that gave me this background as kind of a hacker, you know, a computer hacker, you could say. And so I had a lot of experience with writing code and building machine learning systems. And in 2012, I had this kind of revelation. So I was sitting in a therapy session and I leaned back and I looked at this print that was across the room from me, and the glass covering the print was cracked, and there was this hair stuck in the crack of the glass. And I just sat there and I started looking at this hair and I thought, what could I learn about the person who left that hair behind? And that triggered all of these associations. Had already been thinking a lot about things like electronic surveillance. And looking at that hair, I suddenly realized that all the conversations we were having already then in 2012 about digital surveillance, we weren't having about the body, about our bodies, thinking about what you could read and interpret from the physical stuff of the human body. And so that was kind of the revelation that got me moving into this new direction of biology, molecular biology, and working with DNA. That's been the subject of my work more or less ever since then, since 2012. And when I left that therapy session, I just started noticing things everywhere. You know, it's not just the hair stuck in the glass, it was cigarette butts on the street and people spitting out their chewed up gum, people clipping their nails on the subway, things like that. And so that I started basically collecting those things. So you can see that documented there on the bottom. So I started collecting these samples, and that led me to the community biology space called GenSpace, and I'll come back to that in a minute. Collecting those samples was the starting point for the project Stranger Visions. So this question of how much can I learn about a stranger from a hair? This was the research question that kind of propelled me forward. And I didn't know when I started the project what I would find, what that would mean. And in a way, it has continued unfolding over the years, thinking about what does that mean and what doesn't it mean, and critically reflecting also on what it means and what the limitations and potentials of genomic profiling and prediction are. So in Stranger Visions, I started collecting these samples. I brought them into GenSpace, the community biology lab, extracted the DNA, analyzed that DNA, and used that data to generate these computational portraits representing what someone might look like based on their DNA information. And those portraits I then 3D printed at life size in full color. And I exhibited these along with the sample and information about where that sample was collected and what I had learned about that person from their DNA. And so to do this, I looked at traits that are considered fairly well established, like eye color. I looked at more contentious genetic information, things like ancestry. I looked at genes that are not usually considered controversial, but which I think do demand further analysis and deconstruction, like genetic sex. I looked at speculative science, preliminary studies of things like freckling and facial shape. And I exhibited these portraits on the wall, like you see here. So life size, along with the information about what I had discovered. And so people would walk up to these portraits and have a visceral encounter with a face and a DNA sample and really think, that could be me, that could be my DNA. And what I was interested in that moment was really homing in on this idea of genetic surveillance and presenting this possibility that you could shed your genetic information in public and anyone could come along and mine that for information. And that DNA was increasingly legible. So it was increasingly easy to read DNA. It became faster, it became cheaper, became DIY. So all of these things were really new in that moment still. And so I was trying to get people to think about, what does it mean that any one of us could just pick up your DNA and look at it and cast our interpretations onto your DNA? And the other thing I wanted to call attention to was this emerging technology at that time called forensic DNA phenotyping. So DNA phenotyping is the attempt to predict a face from nothing more than DNA. And the research that I was doing that led me into Stranger Visions, I could see the early traces of this research coming together from scientists around the world. So I could see early studies that people were publishing about analyzing things like eye color and ancestry from forensic DNA samples with the purpose of using that in policing. And so I wanted to also call attention to this emerging technology that wasn't being discussed and to make people aware that this was a technology that was under development, that was coming. I'll come back to that in a minute, thinking about it coming and how soon it was going to come, because in that moment I thought, it's probably 5 years away. So we'll come back to that. I learned in the world's first DIY biology lab. This was GenSpace. This is what it looked like in that moment of time in 2012. So this was the first lab in the world where anyone could come in and sign up for a class to learn the basics of DNA extraction. I don't know if anyone in here does any work with DNA, but amplifying the DNA, sequencing it, understanding, interpreting it, also doing genetic engineering experiments. So GenSpace is a lab and was the first open public lab that invited the community in to learn how to do their own DNA research with really this idea that if you know through hands-on experience with the material of biology, that will really expand your understanding of things like policy related to molecular biology. So to understand things like what kind of policies we might support. It's so helpful to have had that hands-on experience so that you understand what the technology does and what it doesn't. You know, what are the limits of the technology and what are the kind of expansive horizons of it as well. So I come back to GenSpace a lot because I think it's such an important model for thinking about how to bring a public into growing their understanding of a medium, of a new technology, and kind of creating a more informed world so that we can make decisions together that are really meaningful. So I mentioned in the beginning that I had this background in computer science and programming, in AI, machine learning. And so for Stranger Visions, I was putting that together with acquiring these new skills of DNA extraction and analysis. So I was building on facial recognition technology. I had already worked on projects generating faces using facial recognition systems. And what I'd learned in doing that is that you can take a facial recognition system and turn it around into a facial generation system. And so I'd had that intuition when I was working with 2D facial recognition already in my master's thesis back in 2007. And as I went into this project, I wanted to explore this area of 3D facial recognition. I wanted to move from generating 2D images to 3D images. I wanted to be able to make sculptures, portraits of these people. And so I ended up working with an open source project called the Basel Morph Face project, which was a 3D facial recognition system. And what these things are designed for is basically to have a database of people's faces, pictures taken from the front. That's indexed. And then if you have a surveillance camera on the street, for example, and you catch a picture of someone, a person of interest, catch a picture of them from the side, you can project that image back into 3D and match it to the database. So that's the underlying purpose of these kind of surveillance systems that I'm appropriating and turning around. So turning around a facial recognition system, transforming it into a facial generation system. And you can see that kind of morphing face is evolving all these different possible faces. So the other thing is with Stranger Visions, I mentioned I was interested in talking about surveillance. I was interested in talking about DNA phenotyping. I wanted in a way to wake people up, to shock them a bit, you know, to do something purposefully controversial, to get people thinking. But what I did is present one face with one DNA sample. And that is intentionally reductionist. In my process, I would generate 5, 7 different possible faces. And I would look at them and subjectively decide which artistically appealed to me. Which maybe a face reminded me of someone, or maybe the expression made me feel something. And so I would use artistic subjectivity to choose one of those faces. So it was never for me about generating an exact likeness of someone or even trying that. It was really about creating an experience where people would reflect on these politics. And like I said, I thought this was still 5 years in the future. But it wasn't. So at the end of 2014, this company, Parabon Nanolabs, started marketing DNA mugshots to the police. And this is an actual photograph of a clipping that a friend's mother sent me that they'd published in the local newspaper saying, "Do you recognize this man?" And maybe we can just take a moment here to look at what is actually in this profile. What is in this picture? They say it's a male of unknown age, unknown weight, European ancestry, brown eyes, maybe a few freckles. And that's it. So this is basically a portrait of a white man. It's a stereotype that is being put out in the newspaper and asking people, have you seen this man? And at that time, if you looked at their website, you could see this lineup of portraits, and the faces all had the same basic structure. They all looked more or less like the same face with a few features changed. And so when I saw this starting to happen, I realized that I had to really rethink the messaging that I was putting out there, and rethink, how do I engage audiences in thinking about this new technology of DNA phenotyping? It's not enough to get people thinking about surveillance and to warn them this technology is coming, because it's already here. It's already being sold to the police, even if I know that they don't have enough information to really be putting these portraits out there. And so I wanted to try then to bring some complexity into that conversation, to get people to think also critically about the technique of DNA phenotyping itself. And I started thinking, how can I approach that? And so I started giving lectures about it, bringing people in really more deeply to the decision-making process that goes into generating portraits like that. Bringing people into thinking about longer histories around racial profiling, for example, and how these things intersect. And I started writing articles about it, but I was still thinking, how can I bring that also into the artwork itself? And then in 2015, I received this email from Paper Magazine. And they asked me if I'd be interested in working with Chelsea Manning, creating a DNA portrait of her in prison. And I thought about this, and I was immediately interested in doing it. First, because Chelsea Manning was a whistleblower figure who I was very inspired by. So Chelsea Manning was the figure that made WikiLeaks a household word, a household name, exposing the prevalence of torture and civilian deaths in the Afghanistan and Iraq wars through her whistleblowing. So I was inspired by her courage. And she was sitting facing a 35-year sentence at that point in federal prison. But also I realized that working with Chelsea Manning would be an opportunity to really expand thinking about the production of these portraits, to invite people in to thinking about seeing more than one possible face from a DNA sample. And this is because Chelsea Manning is transgender. So when Chelsea was sentenced, she also announced her gender transition at the same moment. So up until the point of her sentencing, she'd been known as Private Bradley Manning. After her sentencing, she came out as Chelsea Manning. And that was also the point at which nobody was allowed to visit her. Nobody was allowed to see her. Nobody could photograph her. Nobody could represent, go in and sketch her, anything like this. So in this sense, Chelsea Manning, her image had been suppressed from the public. And so I realized that this would be an incredible opportunity to take this technology and show some of the complexity involved in interpreting a face from DNA, and to really work with her on thinking through how to do that. And she was excited about working on it too. So she'd seen the Stranger Visions project and was excited about that and the questions that it raised. And Chelsea's also really an expert in computer systems and AI and information processing and things like that. So she totally got it. And so she was interested in participating in this project together. So the next time she was getting her hair cut, she just scooped up some of the clippings, took a couple Q-tips, swabbed the insides of her cheeks, and mailed them to me from prison. And I walked through the same process that I'd walked through with Stranger Visions, analyzing her DNA, but with one crucial difference, that we decided not to look at genetic sex. So we decided to leave that particular parameter out of the genetic profile, and rather to present two different portraits of her that we would show side by side. One algorithmically neutral portrait and one parameterized female portrait. If you think back to the morphing 3D faces that you saw earlier, that the software that I was using for that, it has essentially an algorithmic slider that's built in, where you would move between a male and a female face according to the biases and the structures of that data. And so we wanted to present this so that you could see an embodiment of those stereotypes, so that you could see on the left is the algorithmically neutral face, on the right is the parameterized female face. So you could look at these and think about, what does that even mean? What does it mean to have a female face or a neutral face? And contemplate what a gendered face is even supposed to be. And we were very fortunate in the launch of the project. So the prints, the original prints that were in Paper Magazine, those were 2D prints, but the 3D prints premiered at the World Economic Forum. And this was a really interesting opportunity, because you have to think about Chelsea Manning sitting there in prison. You know, she's been locked up, the key's been thrown away, she's facing a really long sentence. In that moment also, nobody was really talking about her anymore. And suddenly we took her face, we took this image that had been suppressed from the public and put it at one of the most elite political events of the year. So this was a really meaningful place to do this kind of intervention and push her and give her a public position in a venue like this. And the story doesn't end there. So November of 2016, Obama's exit from the White House was looming. And there was a big campaign growing for clemency for Chelsea Manning. And I wanted to do something to assist in that campaign. And so we came up with this idea together to create this kind of comic book that would narrate the story of our collaboration and end with a speculative twist. So Suppressed Images is the name of the comic book. It's online at suppressedimages.net. And I'll just share a few of the frames with you here, so you can see that we depicted the process of working together. So here you see the cheek swabs happening, me sending it for sequencing. Here you see an excerpt from the letters that we exchanged. So corresponding with Chelsea while she was in prison is a complicated matter. Most of the time we were sending letters back and forth through the mail. And I was always worried, I was always being cautious about what I would send her, because you would hear these stories in the news about her receiving a magazine, and it was a contraband magazine, and then she would end up being put in solitary and things like that. And so I was always really cautious with what I would send her and ask her things. And she would respond like this: send me whatever. Let the lawyers work the free speech angle if there's a problem. When they chill your speech, then they've won. So never shut up. And I thought this was so moving at the time, and it's, in a way, it's even more moving now. Looking back at this, I haven't really looked at this in a while. And I think that's more applicable than ever today. And the speculative last frame. So we imagined that that Obama would commute her sentence, and she would be released from prison, and she would come to a gallery and see her portraits in person for the first time. So that's this speculative imagining, you know, putting out this future that we wanted to see, really. And in that moment, everyone told me that it would never happen, that I was wasting my time. But we published it on the morning of January 17th in 2017, and that afternoon, Obama commuted her sentence. And that was really this most incredible moment, to have been working, you know, already for more than a year with someone, and you think through this speculative future together, and everyone tells you it's impossible, and then it comes true. And this was just such an incredible moment of hope. And there she is, standing with, indeed, her portraits at Friedman Gallery after she was released from prison. And so this was the third phase of this research, of this body of work, you could say, working with these DNA portraits. We were invited to have an exhibition in the Friedman Gallery. So this Friedman Gallery had seen the work that I just shared with you, the two portraits that we called Radical Love, and invited us to have a whole show together. And suddenly we had a 1,000-square-foot gallery, and we could think, how could we expand this project? We just have these two portraits. What can we do to like really throw that open, to make that even bigger? And so we came up with this idea of expanding that from 2 portraits to 30 portraits, and using that to create a probability space. If you think about a graph, and you think you have all these different points on the graph, and these are different possibilities, different probabilities. So we wanted to take the gallery space and use that to map out some of the different possibilities or probabilities from her DNA analysis. And so this is what it looked like. So this is probably Chelsea. So it's 30 different variations of Chelsea Manning's face, algorithmically generated from an analysis of her DNA. They're suspended as a crowd. So they are at a wide variety of different heights. The one in the middle is at her actual height. And they show all of these different potentialities that come from interpreting DNA data. And I would say really more than that, it shows how subjective the act of reading data in general is, because it's not just about DNA. You could tell the same story about almost any of your data. So genomic data can tell a multitude of different stories about who and what you are. This installation shows how many different ways that data can be interpreted, and gets you hopefully thinking about what this process of reading from data is, reading DNA data, that reading always involves interpretation. And this crowd that's standing here, this crowd of possible faces, is also meant to invoke the feeling of a mass movement, and to refer back to this mass movement that stood with Chelsea, that advocated for her, release from prison. Okay, so I'm going to jump a little bit now. In working on Stranger Visions and in learning the lab techniques, I discovered that there's this whole world of websites that sell human samples. So here you can see a sampling of these samples. So things like saliva, for example, all kinds of blood, semen, every kind of body fluid you can imagine, but also every kind of cell, isolated DNA. All of these things are available for sale from individuals. So not just amalgams, like you might imagine, but individual single source human samples are available for sale. And I discovered this because when you're working in the biology lab doing experiments, oftentimes you need a control sample. And so you could buy, for example, a control DNA sample to use in an experiment. And that led me to discovering that it wasn't just DNA that was for sale, although that was already a lot. You know, having the human isolated source of DNA is already a very personal and intimate thing. But you could have a whole number of other kinds of samples. So I couldn't really believe it when I discovered this, because they were being sold as if they were anonymous. But I knew already that there was no way of ever making DNA truly anonymous. I knew that any source of DNA could potentially be re-identified. And this is just one example of, there's a lot of different research that's gone into this. But when I was doing my research into what kinds of things you could predict about a stranger from a hair, in addition to the things that are called externally visible characteristics, the things that relate to what someone might look like, this was a scientist, Yaniv Ehrlich, who was researching the prediction of someone's name from their DNA. And it turns out it's actually pretty easy to predict someone's last name based on their DNA. And that research has just continued. You know, this was way back in 2013. And since then, this has grown so much in the meantime. And there's a whole field now of forensic genetic genealogy that involves tracking people down through these networks of DNA relatives, for example. And I'll come back to that again. But I saw this saliva for sale on the internet, and I thought, you know, with Stranger Visions, I'd been thinking about that project as kind of this hacker project, that it shows a kind of vulnerability in our social systems and in the technological systems, that we're not thinking about this vulnerability of our DNA data. But here was another place where I was seeing that our DNA data wasn't being protected. There was a liability in the systems that were storing and selling samples from people. And so I wanted, again, to take this kind of hacker approach to showing a vulnerability by actually performing an experiment. And so I bought the saliva, and I knew that with almost no effort, I could pour that into a kit, into a DNA sequencing kit, and send it for genomic analysis from 23andMe, for example. And that when I did that, I would get back a complex, a comprehensive DNA profile about the person, both in terms of traits that were interpreted about them, and then also in terms of the data file, that I would get the raw data out of that as well. And this process informed the script that I then wrote for the short film T3511, which is a 4-channel video narrative that follows a biohacker as she buys a saliva sample, analyzes it, and then progressively falls in love, essentially, with the donor. So by looking at their data and kind of learning more and more about them, she falls in love with them and ultimately tracks them down. And so I was interested in taking this scientific or technical story and this hacker story and making it intimate and personal by interweaving it with a series of love letters. So the form of the short film, it's told in this way through a series of love letters that she's writing to the donor. And the process that I work from in projects like this and other projects that involve some kind of fiction writing is a process that I think about as writing through. So it's taking something technical or scientific, and then on the other hand, taking my personal experience, taking my intimate emotional experiences, and kind of writing one through the other. So thinking of a love letter that I might actually write to someone, and interweaving these kind of protocols and revelations from the data with these intimate experiences. And what I hope is that by doing that, that it moves beyond something like an article that you might see in a newspaper, for example, that might announce there's been this, you know, there's this possible hack. So I wanted to go beyond that to also connect with the viewer on an emotional or on a visceral level. I felt like I had accomplished that very well with Stranger Visions, for example, with Probably Chelsea, that people walked in and they told me that they had these very intense experiences with these portraits. And so with this project, I wanted, again, to try to figure out how can I bring people into having an emotional relationship with something that is maybe an more abstract kind of biohacker story. It's a 4-channel video. It creates this immersive feeling of being inside a giant biobank freezer. And I'm going to talk more about biobanks, but biobanks basically are these places where things like DNA and cells and blood are stored for the purposes of scientific research and medical research. And I wanted to drive home this idea that we're all part of this system, that we're all in a freezer or in a biobank somewhere. This was my first attempt at getting that across by putting people in the middle of this video that would also have this biobank on all 4 sides, for example, surrounding them. Okay, so I'm going to play you a short excerpt from the film.
A cell is a history. A cell is a home. A cell is a hole. A cell is a cage. A cell is an electric fence, enclosing your legible unknown. To break the cell is to trespass the most intimate of spaces. Dear donor T2305, I received 5 milliliters of your saliva in June. It wasn't hard to get. Using my academic email and mailing address, I simply said it was for research, genetic testing, the truth. When it arrived, I moved it quickly to the freezer to keep it fresh and alive. I sent 2 milliliters of your fluid for sequencing, and then I waited and waited and waited. 6 weeks came and went, and then another time over. The company was experiencing unusually long processing times. When the results finally trickled in 6 months later, I devoured your profile in a single sitting. You are 46 years old with dark brown eyes, a full head of brown hair, and few freckles. You toss and turn in bed, and you enjoy a savory midnight snack. You like to run for miles, for hours, and this keeps you slim, keeps your heart beating strong, and helps tame your sometimes wild thoughts. You were my first, and I think of you frequently. I imagine your face, your voice, the way you walk. I'm curious where you grew up. I worry for your health. And I wonder what you would think of me poring over your genetic details. I'd like to think you would be flattered, but you might be very angry.
How many of you heard of the Golden State Killer case? Good number of you. So T3511 anticipated the technology that would be used in that case to track down the killer. So I could see that these so-called recreational databases of DNA were increasingly accessible, that they were growing bigger. And through my own experiments, I could see how easily you could send a sample, get a DNA profile from that, and upload it into one of these databases, for example, and use that to kind of trace a genealogical path to find relatives of a person. And so this piece was also partially about, again, showing that there's this kind of technology that's coming. And the field of forensic genetic genealogy has actually become a huge one since then. So much bigger than the DNA phenotyping. The prediction of faces from DNA turned out not to be the golden bullet that they hoped it would be. But the forensic genetic genealogy, this has become a huge practice. And the Golden State Killer case, that was in 2018. So that in that case, the suspect was arrested for a rape and murder committed 4 decades earlier. And the way that the police did that was by taking a sample, an original DNA sample from the crime scene, and kind of surreptitiously uploading the data into one of these consumer genetic profile services. It's mostly used by people that are looking for their long-lost families, for example. It's much used by adoptees. And they surreptitiously uploaded the sample and then used that to traverse the family tree to identify the killer. This image, which you saw also in the film, was taken at a biobank in Copenhagen in Denmark. And this is very interesting because I emailed so many different biobanks and asked to film. And this is a recurring theme that we could come back to if we want. I'm always trying to get access to these spaces. And it's difficult because they oftentimes research facilities don't want to give you access for various reasons. But in this case, this particular biobank in Copenhagen invited me in. And they allowed me to film in the biobank. And what you see here is a giant robotic freezer that contains blood from every baby born in Denmark since 1982. So this is where we filmed. And that's the story in Denmark. They have a very kind of tightly organized system where every baby born has their blood in this one biobank. It's linked to their medical records. You know, it's very highly centralized. In the United States, things are more patchwork by the state. But nonetheless, every baby born in the United States also has their blood sitting in a biobank somewhere, at least for 10 to 25 years. And further, every time you have your blood drawn, every time you have a biopsy, urinate in a cup, have your nose or your cheeks swabbed, those fluids and cells and data can have a very long afterlife. So many of you might have read the book, The Immortal Life of Henrietta Lacks, for example, or seen the film, popularized by Rebecca Skloot. So it tells the story of Henrietta Lacks, who's an African-American woman whose cervical cancer cells were taken at Johns Hopkins Hospital in the 1950s without her consent, and went on to become the world's first immortalized cell line. So the first cell line that could be used for research without taking more and more samples. And that book popularized this interest in thinking about medical ethics in regards to cell lines. But what is not so popularly understood is that the story of Henrietta Lacks was the first instance of a process, of an approach that has become really commonplace. So in this sense, now we've all become Henrietta Lacks because all of our samples can be used in that way. And that's totally legal and legitimate research practice. Basically, when you go into the hospital to have your procedure, you sign away any rights that you would have to ownership over those discarded samples of your body. And so I've been interested in these biobanks for a long time, and we were talking in the graduate seminar a bit about that last night, about these kind of long burning projects where you start working on something or thinking about something years earlier, and then you keep coming back to it, you keep kind of pushing the research forward and learning more and experimenting more. So T3511 I was working on in 2016, that's where I started really mapping out this system and looking at the commodification of cells and DNA samples. And then this project banked in 2025, which is part of a big installation called Is a Biobank a Home? This, in a way, is the culmination of that research interest in getting people to think about what it means to be sitting in a biobank, how to reflect on your privacy, the significance of your genetic material, and the cellular material also that sits in these freezers, for example, for decades. So all of that went into inspiring this newly commissioned project for the Cooper-Hewitt Triennial where I wanted to really create the actual feeling of walking into a biobank. So thinking about when I stepped into that biobank in Copenhagen, what did it feel like to stand in that robotic freezer? So for this project, I wanted to make this room very cold, and have people walk in and walk into this labyrinth of samples So they'd be surrounded by these blood samples and convey this feeling of really that, again, that this could be your sample, that we're all in a biobank somewhere. And so there's 7,000 vials of blood in the exhibition. It has an installation with fans, cold air blowing. There's sound recordings from that biobank playing in the installation. And this labyrinth-like structure that encloses you as the viewer. Each of the vials of blood is individually barcoded, and they represent essentially that each of these samples would be an individual person. And that was the architectural kind of impulse behind the piece. And the context was the Cooper Hewitt Triennial. The Cooper Hewitt is a design and architecture museum. And so our starting point for that was an interest in thinking through the structure of these kinds of spaces. But I wanted to add another layer to that experience. So I was interested in having the immersive experiential aspect, but I wanted also to have something more personal layered in with it. And so I started this process of contacting a number of medical institutions. I can't say all, but many of the medical institutions that I have been a patient at, starting with my own newborn blood. So I was born at Pennsylvania Hospital. So I started out by contacting Pennsylvania Hospital and asking the director, could I obtain my own newborn blood spot? And she said that it had been destroyed. So they keep them for 25 years. So I was a little bit too late to get my own sample. But it started this process. And so I corresponded a bit with her, and I asked if I could have any more details about how they approach storing the samples, anything like that, if there was any place I could visit, and so on. And then she said that everything was off-site and they use a third party. And this is a common refrain, that there's a lot of third parties involved in storing our data, storing our physical samples as well. And then I started to contact medical institutions I'd been a patient at more recently. So I contacted Weill Cornell Medical, Columbia, and NYU Langone, and just started to make these requests and ask, have you used my cells for research? Where is my data? You know, what will you share with me? And mostly they said, we don't have to tell you. So this was the default response, was that the institutions would write back and say, we don't have to give you that information. We're not required by law to tell you that. One exception really was they will tell you if there's been any requests by law enforcement for your biological samples. So they don't have to tell you that in general, but if you make a request and ask, then they do have to tell you. And the other exception was that you can access your own biopsies, like the physical material that's taken from your body, at least in many medical institutions, that physical material is saved for some decades. And so what they will do is they'll slice off a little sliver of that and put it in a slide and send it to you. And so that's what you see here in this stained glass window. So I received my own biopsy slides and set them in stained glass. And I started to think about the biobank as also being this kind of sacred experience, this very personal experience of transforming something painful into something beautiful. And here you can see a close-up image of what the slides look like in the stained glass. So adding another layer to this experience, thinking about how do I incorporate the story of me looking for my data into a meaningful way. And this led me also into taking that correspondence and turning it into a song. So I worked with the composer, Nikki Main, and I wrote out a libretto from these email exchanges that I had. So basically, I created this master document that had all of these emails. You know, a lot of me saying, can I have my data? Can I have my data? And people writing back and saying, dear Miss Dewey-Hagborg, basically, no. But thank you for your request. So I have all of this data, and I started analyzing it and looking at what are the most commonly occurring words and phrases and pulling those out and turning that into the text that could form the basis of a piece of music. And so I hope that this piece of music, when you walk into the installation, kind of walk through the labyrinth of the biobank and you emerge at the end and you walk into this bay window that has the stained glass and you can hear the song coming down, kind of streaming down on you. And I hope that that furthers this feeling of kind of the sacredness of this data, the significance of this data. And there's also kind of an absurd and comical twist to it. So I'm going to play the piece of music for you as well. So I think it brings together the absurdity of my effort of trying to track down the data, how comically difficult that is. Also, this kind of a sense of loss at being detached from these bits of myself, that we're at a distance, that I'm not in control, that I don't really have agency over my own body and my own data. And yes, and the futility of these efforts. So I'll just take a minute to play the musical piece for you as the last element of my presentation.
Dear Miss Dewey-Hagborg, dear Miss Dewey-Hagborg, thank you for contacting. Thank you for contacting disclosures of de-identified information. Dear Miss Dewey-Hagborg, thank you for reaching out for an accounting of disclosures.
Neither New York nor federal law nor the statewide health information network require us to account for uses and/or disclosures of de-identified information. Thank you for reaching out. Unfortunately, we are not able to provide you with such information. Please be assured that we value our patients' privacy.
Thank you.
Thank you so much, Heather, for sharing with us more about DNA, so much that we didn't even think about. So now the floor is open up for questions. So I would like you to raise your hand if you have questions, and I will bring the microphone right up to you. Questions?
Maybe we could bring the lights up a little bit.
Yeah.
Yeah. Great. Thank you.
On the stained glass structure, is there any like connection to maybe your heritage and things like that as well? Or I mean, the architectural itself, did you go that deep? I was just curious on that.
So the form of the stained glass is maybe more connected with personal experience rather than heritage, so to say. So this is a form that's used in a lot of churches in Europe. So my partner is German, and I spend a lot of time in Germany. We visit a lot of historic churches. And my impulse when I walked into the Cooper Hewitt, so the room where we did the installation, interestingly enough, I have to take a step back, sorry. So the Cooper Hewitt Museum is inside of the Carnegie Mansion. So it's this kind of Gilded Age mansion. And the room that the installation took place in actually was the nursery. So that was a really amazing kind of connection. And then when I started to think about it as some kind of almost sacred experience, I started thinking about my own experiences and which forms of religious architectures had made me feel something or connected with me in some way. And I always really loved these stained glass windows in Germany that have these rondelles, you know, these round cast glass components, and are these very, very light pastel colors, you know, really bring the light in, almost are clear, but have these light hints of color to them. And then you also have the reference to the cell, to the microscope. And so I liked this kind of layering of drawing on something that I personally experienced and found meaningful walking into those spaces, and then kind of a small kind of nod to a conceptual layer around the shape of the cell and things like that. But mainly also working intuitively, I would say, on that. And I worked with a stained glass fabricator on that who had a lot of experience, and you know, she also was really excited to try to work on setting the slides into these rondelles. Thanks.
Thank you for that fantastic talk. So one thing that this got me thinking about is I'm a microbiome scientist, and we are learning that much like genomes, two people may share a lot of microbes in common, but everyone kind of has an individual fingerprinting of their microbes that is, you know, self, but also not self. And I'm wondering if you have thought about this in your work, or maybe plan to think about that in some way as well?
So if you were to rewind the clock to 2012, when I first started working on Stranger Visions, I imagined that project growing all of these kind of tentacles, and I thought I would look into epigenetics. And then when the microbiome came, I thought that would be also so interesting to add these layers in. And in a way, I'm still interested in that. But that project, what I didn't say is that project was this kind of, I saw it as a work in progress. And then at one point, I just felt like I had to move on. Like it had absorbed my whole life, and I needed to try to do the next thing. And so I started thinking about these predictions and profiles in a different way and through different media and so on. And so I think that the microbiome would be a fascinating subject to approach in terms of thinking about profiling and prediction. Absolutely. I haven't done anything in my own research around that, but I could absolutely see that as part of, predicting a portrait of someone, but also thinking about tracking someone down by their microbiome. All of those things I think could absolutely apply and would be really interesting to look at. And then I would say that more recently also I've been looking at these attempts to predict behavior from DNA. And so my interest in all of that stuff definitely continues. It's just that I'm trying to look at it now from other vantage points, I guess, or with other outputs in mind.
Thank you so much for that amazing talk. I am just curious, this is maybe a very personal question, but I'm curious how you now currently sort of look at the clinical world and what choices you make personally when you are faced with having to give a sample, a specimen, a donation, and what choices you make based on your knowledge.
Absolutely, absolutely. So I think the first thing I always do is I read the paperwork. This is the first, I think, major change, because usually they hand you a big packet, or even worse, they'll hand you a tablet to sign with a link to the privacy policy, for example. So now I always take the time, I sit down, I read through the things. People are often really surprised in medical institutions that I sit there for 10, 15 minutes and want to actually read what they're saying they're going to do with the data. But that's the first step. The second step is that I often don't consent. So it says, can we use your data for research? And often I think it's easy to feel pressured into saying yes, because I don't know, it's not totally clear that if you say no, that you can still get the treatment, for example. So this is another thing that I'll often do, is I'll just say, no, I don't consent to having my data used for research, especially if it's just a blanket research policy. So a lot of these forms, they'll just say, we can use your data de-identified for anything we want. And sometimes you can't opt out. It's that simple. But sometimes you can. And so I try to read what they actually say they're going to do, and then make a decision based on that. So for example, if they say, we're going to do this constrained kind of research, like we'll take, if you allow us, we'll save your sample and we'll use it for just this particular area of research, then I'll usually say yes, because I feel that that's meaningful and that I personally want to contribute also to medical research on things that, for example, have affected me personally. And it's a very individual decision, I think, making those choices. And I feel like there was something else I wanted to say about that. So thinking about those things, the decisions that I make, I felt like there was one more point I wanted to make about that, and I'm now not thinking of what it was, but yeah, so I generally do those things. Sometimes people ask me about like giving birth and the newborn blood spot, for example. So when they come and they take your newborn's blood, and then those get stored and so on. And that is one of these moments where, you've just had a baby and the last thing you're thinking about is reading a bunch of forms or thinking about privacy implications and so on. And so I would say that I also, when I gave birth to my baby, was totally overwhelmed and not thinking about it when they took their blood, but I had thought about it ahead of time, I guess you could say, since I'd just been doing all of this research and worked on this project. So I know that their blood will be stored for 10 to 25 years. And I know that it will be in New York State, so it will have certain protections, but those can always change. And what I didn't get into in this slide presentation, for example, was that there was a recent case in New Jersey where parents actually sued law enforcement for examining samples in the biobank, in the newborn blood biobank. So they were, again, doing this kind of cold case, looking for someone, and they went in and actually started looking at these DNA samples from newborns to track the person down. So those things are, again, they're not science fiction. They're happening, even if it's not an everyday occurrence. It's happening right now. So I try to weigh the pros and cons of those things. So, for example, I definitely want to have the newborn testing. I wanted my own baby to know if they had any early diseases that could be treated, for example. It's a really meaningful program. And so I would never really want anyone to come away from a talk like this and think that they should opt out of things like that. That's not what I'm trying to say. What I'm trying to say is that we should approach these things with much more care. That we should really think more systematically in the medical institutions about how we're treating people's data and understand that they are never anonymous. Yeah, but it is always difficult to make those decisions.
Last question for the day.
This might be a little circuitous, so I apologize, but I'm trying to think while I'm speaking. One of the first things that I saw the police put out after the shooting last week was an AI enhanced picture of the ostensible shooter that kind of looks like him, but not really because it's very high resolution,
Yeah.
but it's AI filtered. How do you see the role of the artist or fine art in critiquing and consciousness raising about this type of thing in the face of political systems that seem so unmovable off of trying to enhance their capabilities in ways that aren't very accurate or
Yeah.
aren't
Yeah.
good?
This would be such a great opportunity to do one of these projects showing multiples. If you think about the AI enhancement, there could be so many different AI enhancement. You could show different faces that were AI enhanced, for example. And I can think of a lot of different ways you could approach that. But I think that would be a really meaningful project to do, actually, to put these out and show that the image enhancement is not just like an objective tool.
Also, you don't mind, the fine art has such a small audience in comparison to culture at large, but the ability, like the pieces that you're making are so powerful, but they're so specific. Like, how do you conceptualize the role of the artist in being able to critique society in that way, in a way that lots of other people can't?
So I think fine art, so the audience for fine art can be very small, but it can also be very wide, depending on where that work circulates. And so what I have really enjoyed doing in my practice is making work that can circulate in many different kinds of spaces and different kinds of discourses. So yes, it can sit in a commercial gallery, but it can also sit in a science museum, for example. And it can also, for example, I've presented my work at the Woodrow Wilson Center for Public Policy in DC, and in technology conferences. And it's been on the news, but it's also been in art publications. So I think what I try to do with my work is to enter all of these different spaces to get a lot of different audiences to be exposed to the critiques and to the ideas. And so I try to spend a lot of time also talking with molecular biologists and people who are very much involved in doing this kind of research, making these decisions on a daily basis, often without really thinking about the implications of it. And so that has been a process of entering these different forums, legal studies and the sciences and politics, and trying to reach as many people as possible in these different ways. So one of in the list of the acquisitions earlier, the fact that the Exploratorium acquired probably Chelsea. This for me is really one of the things I'm the most happy about, because the Exploratorium is this science museum in San Francisco, and that hundreds of thousands of kids are going to be introduced to ideas in molecular biology walking through this installation about Chelsea Manning. And that, to me, just feels like such a win to get complexity right there at the entrance point. But I mean, it's not the most obvious thing to do as an artist, right? I mean, the thing we're usually trying for is to have shows in art spaces and more prestigious art spaces and so on. That's kind of the default thing that you do as an artist. But I think that what I've been trying to do is to travel a more complex or a more varied terrain with the work.
Thank you.
Yeah.
Thank you so much, Heather. And thank you, everybody, for joining us today. We will be here same time next week. We have another artist talk, so I do encourage you to bring someone along. And thank you all. So I'll see you next week.